Hello everyone. In this video, we're going to talk about special types of series called power series. A power series is a series of the form sum from n equals 0 to infinity of cn times x to the n, where x is a variable and the cn's are constants depending only on n. A simple example of a power series might look something like the sum of x to the n over 2 to the n. Notice that the terms of a power series are not numbers, like we've seen up until now, because they contain the variable x. And so, it doesn't make sense to talk about convergence or divergence of these series unless we plug in a value for x. In particular, a power series defines a function. F of x is equal to the sum from n equals 0 to infinity of cn times x to the n. Now, we can ask the question, what is the domain of f? The series may diverge for some x values, and so it wouldn't make sense to plug those values into f. And so our goal for the remainder of this lecture is going to be to find the x values at which a power series converges. Let's try this with the example we gave earlier, the sum from n equals 0 to infinity of x to the n over 2 to the n. Notice that we can rewrite this expression to get the sum of x over 2 to the n, which is a geometric series with common ratio x over 2. Therefore, by the geometric series test, the series only converges if the absolute value of x over 2 is less than 1. In other words, we need the absolute value of x to be less than 2, or x to be in between -2 and 2. So, we have found that the domain of this function is the interval -2 to 2. Now, what about for more generic series? When do they converge? Well, first notice that when we plug in 0 into a power series, almost all of the terms vanish. And so, a power series will always converge at x equals 0. However, what if we wanted the series to converge at a different value? It turns out we can actually modify the form of our power series to make it converge at any value that we want. We define a power series centered at a to be a power series of the form sum from n equals 0 to infinity of cn times x minus a to the n. Now, just like how almost all of the terms vanish before when we plugged in x equals 0, almost all of the terms of this series vanish when we plug in x equals a. Alright, so we have found one special value at which a power series will converge, and in the next video, we'll talk about how to find the rest.